Hi. On May 5th, the Crescendo hard fork will finally roll out on the Caspa network. And we all know what that means, right? 10 blocks per second. But what is the significance of 10 blocks per second? When asked, many people will say that the motivation for 10 blocks per second is throughput. These people are wrong. I am Dr. Shai Wyborski, and this is the first episode of the Caspa Deep Dive. Caspa is, by any metric, a success. A fairly launched, community-based project with hardly any resources, no marketing team or budget, maintained by a bunch of geeks with no business experience, propelled by a shoestring community into a flourishing ecosystem supported by a massive industry. But the consensus engine that drives Caspa has hardly changed. Since its humble beginnings, barring a few localized fixes in its early days, the Caspa protocol remains the same since it launched. As the community around Caspa became more massive, a change was ripening. Finally, core devs Michael Sutton and Ori Newman stepped up to take it to the next level. They raised a community fund and assembled a team of dedicated contributors to rewrite the Caspa codebase from the ground up in the Rust programming language. A project since known as Caspa on Rust, though I prefer to call it Rusty Caspa. Michael wanted to rewrite the code in a performance-oriented language with a performance-oriented state of mind. And he set his eyes on an ambitious yet attainable goal, 10 blocks per second. But as time passed and the work progressed, so did the discussion around Caspa evolve. New ideas started to emerge. Old ideas that lay dormant since before launch were recalled. Many insightful means to improve the consensus engine and allow new, exciting features accumulated and rolled into a behemoth of an update. This is the bravery to innovate upon your innovation. This is the humility that drives a constant desire to improve. This is the Caspa community, taking all that it has learned in the last 3 years and forging it into a new, better Caspa, a Caspa 2.0. This is Crescendo. When asked, many people will say that the motivation for 10 blocks per second is throughput. If we wanted to increase the throughput, it would have been much easier to just increase the block sizes. Increasing the block rates beyond a couple of blocks per second has completely different motivations. The three that I find most striking are decentralized mining, internet-fast confirmations, and multi-leader consensus. Let's take the time to dive into each one of them. They say that mining, especially ASIC mining, is an economy of scale. And they are right. But what they hardly ever discuss is the scaling factor. And the scaling factor is BPS. So how do high block rates decentralize mining? In a network where the block delay is 10 minutes, only 144 blocks are produced each day, which means the network can only accommodate up to 144 different entities, say solo miners or mining pools, who enjoy a daily income. Worse yet, the noisiness of the block production process renders the income fickle and unpredictable. This sparse and irregular income stream incentivizes all but the largest miners to join a mining pool. Post-crescendo, Kaspa could accommodate up to 864,000 entities who enjoy a daily income. That's why Kaspa is the only cryptocurrency where small home miners are still top sellers, despite the availability of more profitable enterprise-grade machines. With block delays significantly shorter than the network round-trip time, a transaction might be included before it even reaches all miners, making mining more competitive. High block rates make it more feasible for service providers to mine their own blocks. Imagine a wallet, a layer 2 provider, or any other business that generates transactions for its users. They are forced to broadcast their transactions to the network and rely on miners to pick them up. With many blocks per second, much more services could mine their own blocks. A user only needs to know that the service provider queued their transactions, and shouldn't care about the global fee market. And services can react to users faster than the round-trip time. Finally, businesses who mine their own blocks do so independently of the global fee market, compensated for their mining by the users of their service, creating additional sources of security subsidy. Crescendo is fast, but how fast? Will Kaspa confirm transactions 10 times faster after it is rolled out? Not so fast, little grasshopper. We are used to think of transaction confirmation times, at least in proof of work, as completely dominated by the block delay. This makes sense when the block delays are much larger than the network round-trip time. But Kaspa was built around the GhostDAG protocol, whose claim to fame is exactly removing this obstruction. By accommodating parallel blocks, we can set the block delay as short as we want without compromising network security. But when the block delay is already significantly shorter than the network delay, making it smaller will not make confirmation times faster. Think about it. You cannot possibly confirm a transaction before most of the network even heard of it. It will still take the same time for miners to receive the block containing the transaction. Up to that time, they will mine parallel blocks that do not add confirmations to the transaction. In concrete numbers, 1 second is quite comparable to the actual network delays. Pre-crescendo, the block delay still plays some role in the confirmation times. It is hard to say exactly how much faster transactions are going to confirm, but testnet measurements suggest it should be around 30%, reducing the typical waiting time from 10 seconds to 7 seconds. However, it is possible to confirm transactions faster. At some point, the DAGNITE protocol will replace GhostDAG, providing the only decentralized ledger that can react to changing network conditions, eliminating the need for a safety margin to maintain security even if network conditions deteriorate. but this is a discussion for another video. Until then, we can only wait for the internet infrastructure to catch up with Kaspa. Hi, I hope you enjoyed the video and thank you for watching. Before moving on to part 3, I have to ask for your help. While I tremendously enjoy making this content and teaching the world about Kaspa, I cannot do it sustainably by myself. To make this video, I had to research, script, write, edit, program, and do everything else that you have seen. While very fun, this also requires a lot of time. Consistently creating quality content requires working at least 3 days a week. So how can you help? First, like and subscribe. I know all YouTubers ask for it and I know it's annoying, but it's free, it takes literally a second and it really does help. Beyond that, I would really appreciate if you would consider contributing to my content making via my Patreon, Boosty, or Buy Me a Coffee page. You can contribute any amount you want, either monthly or one time, and any cent you contribute would go towards making consistent quality crypto and Kaspa content. You are welcome to check out my website and look at my other projects, and there are also crypto addresses you could use to contribute if you prefer. Currently, this project is new and still taking shape, so there aren't any tiers for contributors, but I have every intention to include contributors in the creative process. Thank you for watching and please enjoy the rest of the video. Multi-leader consensus is a striking consequence of high block rates, allowing unique game-theoretic solutions to holy grail problems. Security budget, the problem of creating sufficient incentives to mine the network even after the entire supply has been emitted. Miner extractable value, the problem of profits exclusive to validators by manipulating the order of transaction inclusion. And decentralized Oracle implementation. The problem of providing smart contracts with a reliable and decentralized source of information about the outside world. In my opinion, this is the magic property that makes Kaspa stand out as a cutting-edge, uniquely powerful cryptocurrency. To understand the significance of multi-leader consensus, let us ask ourselves a simple question. Can a miner always know how much fee they will earn if their block is accepted? In regular blockchains, like Bitcoin, miners compete to place the next block. But the miner knows that if their block was chosen, it completely determines how the state of the network progresses this round. In particular, they know that they will get the fees for all the transactions in their block. In GhostDAG, this is no longer the case. While mining the block, a miner can't know whether parallel blocks contain the same transaction. And if they do, which of the miners will get the fee. GhostDAG resolves any such conflicts retroactively in a non-gameable way. This incentivizes miners to avoid transaction collisions. Instead of choosing the highest paying transactions, it is more profitable to introduce some randomness, prioritizing transactions that pay higher fees by selecting them with a higher probability. This is enough to shatter many of the pathologies of Bitcoin's fee market. In particular, higher fees entail higher quality of service even when a fraction of the network is utilized, avoiding the notorious race to the bottom other proof-of-work chains experience when they are not fully congested. In a recent 4-post series, I explain in excruciating detail how other pathologies of Bitcoin's fee market are a consequence of its single-leader nature and how they are assuaged in multi-leader consensus. But this is just the tip of the iceberg. Multi-leader consensus can be used to impose more complicated protocols among miners, like bidding on the privilege to process a transaction, or aggregating the responses to a question about the outside world. These two ideas are researched by Jonathan Sompolinsky and Elliot May. This is not directly related to Crescendo, so I will probably talk about it in a future video. In the meanwhile, you can enjoy Jonathan's lecture in the Australia Crypto Convention 2024.
Lots of the activity in Ethereum is around these concepts of server manipulation or miner manipulation, sequencer manipulation, revenue, MEV. In the future, Kaspa will operate with 10 blocks per second. The impact on the competitiveness of sequencing is large, and let me now dive into this.
The bottom line is that Kaspa could furnish unique solutions to important problems. Solutions that cannot be implemented on any other cryptocurrency.